This is the B3C3P3 higher 6th pass paper. Remember, you've always got these equations in front of your paper, especially important for the physics section. We'll start with the biology section. So the first question is about DNA. Erwin Chargaff was an Austrian scientist. His work was important in helping James Watson and Francis Crick work out the structure of DNA. Chargaff discovered that in any piece of DNA, the number of A bases is always the same as the number of T bases. Also, the number of C bases is always the same as the number of G bases. In one piece of DNA, 27% of the bases are A. Use Chargaff's discovery to work out the percentages of each of the other bases. So, it told you that T is the same as A, so T will equal 27%. And then what you've got to do is just work out what's left over. So, it's going to be 100 take away 27, take away 27, which equals 46. And then because both C and G must equal the same amount, then they must be 23% each. So if you got all of them correct, it's 2 marks. If you got 1 or 2 of them correct, it's 1 mark. Suggest how Chargaff's discovery helped Watson and Crick work out the structure of DNA. So first mark is for, or 1 mark you can get for the idea of base pairing. But if you said that A pairs with a T and C pairs with a G, that'll get you both marks. In 1962, Watson and Crick and another scientist, Maurice Wilkins, received the Nobel Prize for their discovery of the structure of DNA. Controversially, other scientists whose work had helped Watson and Crick did not receive the prize. These included Chargaff. Some people think that Chargaff should have been included in the group receiving the Nobel Prize. It's just one reason why he should have been included in the group. So, if you put something that, like, Watson and Crick couldn't have produced their model without Chargaff's discovery, or without Chargaff's information they couldn't advance their work, something like that, that's what you want for the mark. It's just one reason why he should not have been included in the group, and it's the idea that Watson and Crick were the ones who came up with the structure of DNA, or we could say that Chargaff did not come up with the structure of the DNA, or that he wasn't in the group that came up with the final discovery. Egg white contains protein. Natasha is investigating how a protein-digesting enzyme called pepsin breaks down cooked egg white. The pepsin breaks down the cooked egg white. This makes the mixture in the test tube change from white to colourless. Natasha times how long it takes for the mixture to go colourless at different temperatures. She keeps everything else the same. The table shows her results. Look at the results. What is the optimum temperature for the pepsin? So the optimum temperature is going to be the temperature at which between which the time is the lowest. So the time the lowest between 35 and 40. So the temperature in between these two is going to be the optimum temperature. So it's 37.5. If you put any answer in between 35 and 40, then that would also be fine. Describe and explain what results you would expect if the temperature increases above 45. So you get a mark for saying that time gets longer or the rate gets slower. You get a mark for saying the reaction stops or the protein is no longer broken down, and a mark for saying because the enzyme is denatured. Proteins have many jobs in the body. Proteins can be broken down in aerobic respiration. They have a respiratory quotient of 0.9, and that's how you work out the respiratory quotient. So when proteins are used in respiration, how does the volume of carbon dioxide produced compare with the volume of oxygen used? So that is that the volume of carbon dioxide is less than the volume of oxygen if the RQ is 0.9. Apart from being used in respiration, proteins have many other jobs in the body. Write about other jobs of protein. So 3 marks here, so any 3 of these. So you can say have a structural job, i.e. making collagen or keratin, hormones, for example insulin, and carrier molecules, for example hemoglobin, or enzymes or biological catalysts, for example amylase. Now you didn't have to put the examples, they would get you a mark, but if you just had any 3 of those 4 different types, that would be fine, or any 3 of the specific types, that would also be fine. You'd also get a mark, in that previous question for saying muscles or growth or repair. The picture shows Dolly the sheep. Dolly grew from an embryo implanted into a surrogate mother sheep. As the embryo grew, its cells divided. Write down the name of this type of cell division. So this type of cell division is called mitosis. And the next question is a 6-mark question. Please can you mark this yourself using the mark scheme that we can find on the Blue Coat Science Google site. If you're unsure whether you've marked it correctly, please ask your teacher just to check it over for you. During the wartime, some emergency transfusions were made using the watery juice from coconuts. This was done to raise the blood pressure of wounded soldiers who had lost a lot of blood. Coconut juice is used because it is at the right concentration and it is sterile. Why is it important to raise the blood pressure of patients who have lost a lot of blood? So this is the idea that you've got to maintain the rate of the flow of blood. So to increase the speed of blood or make the blood flow faster will get you this first mark. And then that has to be linked to the idea that it increases or maintains the transport of materials around the body. So for example, oxygen or food. So those are your 2 points. You might expect lactic acid to build up more quickly in patients who have had transfusions with coconut juice than in patients who have had transfusions with blood. Explain why. And that's because there are less red blood cells or less hemoglobin, and therefore less, so that the lack of oxygen causes anaerobic respiration. So the idea there's less red blood cells, the idea that because that means there's less oxygen, that means that cause anaerobic respiration, which creates lactic acid. So now into the chemistry section. It says graphite is one of the allotropes of carbon. Graphite is used to make pencil leads. Explain why the properties of graphite make it suitable for pencil leads. So first mark saying that it's slippery, or that the layers can slide over one another. And the second mark saying that it's black, so it can be seen on the paper, or it leaves a mark on the paper. Graphite is used in electrode and electrolysis. This is because it conducts electricity and has a high melting point. Explain why graphite can conduct electricity. Use a diagram to help you. So just that it's saying that it has free electrons or mobile electrons or that electrons that can move or delocalize electrons, that'll get you that mark. Explain why graphite has a high melting point. Use a diagram to help you again. So first mark saying that it has many covalent bonds or it has a giant structure. And then a mark for saying that the strong bonds need to be broken or that it needs a lot of energy to break the bonds. So those are your 2 marks. One for talking about that it has many bonds, and the second mark for saying that they are strong bonds that need to be broken. So this next question is part of the 6-mark question. And what I'd like you to do is mark this yourself using the mark scheme, and then ask if you need it checked. But this part is not the 6-mark question. It says, Rachel repeats experiment 1. This time she uses acids at a higher temperature. Explain using the reacting particle model what happens to the rate of reaction. So this is the idea that the rate of reaction will increase because the particles have more energy, or the particles moving faster, or there's more collisions per second. And the second mark is saying that they're more successful collisions because they're more energetic, or more collisions are more energetic. Ethanoic acid can be made by several different processes. Three of these are process R, S and T. In process R, methanol reacts with carbon monoxide. Process R has 100% atom economy. Explain how you can tell this from the symbol equation. That's because there is only one product, or you could say that there's no waste products. That would get you that mark. In process S, sodium ethanoate reacts with sulfuric acid. Look at the table of relative formula masses. A mass of 8.2 grams of sodium ethanoate reacts with excess sulfuric acid. What mass of ethanoic acid can be made? So the first thing to spot is that the ratio is 2 to 2. So for every 2 sodium ethanoate molecules that use 2 ethanoic acid molecules are made. So first thing to do is do 8.2 divided by the relative mass of the sodium ethanoate, which is 82, and then times that by the relative mass of the ethanoic acid, which is 60. And so what that will give you is 6 grams. Calculate the atom economy of process S. Sodium sulfate is a waste product. So atom economy, remember, is the relative mass of the desired product over the relative mass of all the products. So that's going to be 2 times 60. You've got to take into account that big 2. divided by 2 times 60 plus 142 times by 100, so that should equal 45.8. If you put 46, that would also get you both of those marks. In process T, hydrocarbons are oxidized to make ethanoic acid. Mike predicts that 5.2 tons of ethanoic acid should be made. The factory actually makes 2.4 tons. Calculate percentage yield and give it to two significant figures. So percentage yield is actual yield, which is 2.4, divided by maximum yield, which is 5.2, then times by 100. Now that equals 46.154, but just two significant figures, it'll just be 46. So you must put that for 2 marks. If you put 46.154 or put it to more than two significant figures, that'll just get you 1 mark. Describe one disadvantage of having a percentage yield of this value. So it's the idea that you waste a lot of the starting materials, or you waste reactants having a percentage yield that's quite low. So next question, paraffin is a liquid fuel. Paraffin releases heat energy when it burns in air. Jenna wants to find out how much energy is released when she burns 1 gram of paraffin. She decides to use the paraffin to heat some water. Write about how she does the experiment. You may should include a label diagram, which would be a useful thing to do. It's 4 marks this, so a diagram is probably a good idea. So what you want is a copper can with some water in. You want a spirit burner. And you want to label this, so copper can. You want a certain mass of water, so 100 grams would be good, but any other mass is fine. You want a thermometer. And this is liquid fuel. Now the marks here for having correct use of spirit burner, so not having a Bunsen burner, having a container of water above the spirit burner, saying that you'd measure the change in temperature of the water, so that's something you'd have to write rather than label, saying that you'd measure the mass of the paraffin before and after, and you could get a mark for the idea of repeating the experiment. So, next section is physics. Colin walks to school. Look at the graph representing his journey. Use the graph to calculate Colin's average speed for the total journey. So remember that speed equals distance divided by time. So total distance was 1,000, and the total time was 900. Oh, sorry, not 900. Careful there, it's 800. So 1,000 divided by 800 is 1.25 meters per second. Use the graph to calculate speed in part C of the journey. So part C, you're going from 500 up to 1,000, so it's 500 for your distance, and the time is from 550 to 800, so that is 250. So that's 2 meters per second for the second part of the journey. Daisy is going to buy a car. She looks at some data about 5 cars. Which car is the most economical to run over a journey of 50 kilometres? So C is your answer there. It says Daisy takes car A out for a long test drive. The manufacturer states that it will use 4.6 litres of fuel for a journey of 100 kilometres. She finds it uses more fuel than this, suggests reasons why. So any two of these, you could say that her speed would be changing because traffic is heavy, or it needs to stop and start a lot, or there's lots of braking. You could say that the load of the car might be higher, so a large load carried. You could say there's more passengers. You could say she might be towing something, or the windows might be open. You could talk about road conditions, so you could say it was hilly, or there's lots of bends, or it's wet or windy. Or we could talk about her driving style, there could be heavy braking and rapid acceleration, or using the wrong gear. So any two of any of those would be fine. Daisy considers getting an electric car. Her friend tells her they have lots of disadvantages compared with petrol or diesel cars. Write about the advantages and disadvantages of electric cars. So you can have a maximum of 2 advantages. So you could say there's no emissions at the point of use. You could say it's quieter. You could say it's cheaper to run, or it has no road tax. You could say you're conserving fossil fuels. and you can have a maximum of 2 disadvantages. So you could say it has a limited range, we need frequent recharging. You could say it has a limited speed. There's not many recharging points across the country. You could say the batteries are expensive to replace. So any 2 of those would get you maximum of 2 marks of those. So next question is your 6-mark question. So what I'd like you to do is mark this yourself and ask your teacher once you've marked it if you're unsure whether you've marked it correctly or not, just to check it over. Emma drops a rock from the top of a cliff. The rock has a mass of 0.5 kilograms. As the rock falls, it loses potential energy and gains kinetic energy. The rock is travelling at a speed of 50 meters per second. Just before it hits the ground, calculate the distance the rock falls, take the value of G to be 10 Newton per kilogram, ignore the effect of air resistance. So this is the idea that the kinetic energy will equal the potential energy they had at the beginning. So potential energy equals mass times gravity times height, and kinetic energy equals half mv squared. So you can cancel out the masses, and therefore you then get half v squared equals g times h. So v is 15, so half times 15 squared equals g, which is 10, times the height, so 10h. So that means 15 squared will equal 20h. 15 squared is 225, which will equal the 20h, and so h equals 225 divided by 20, which is 11.25. If you did it a different way, that's fine, as long as you got the answer at the end. 11.25 will get you all 3 marks. Emma drops another rock. The rock has a mass of 1 kilogram. The rock hits the ground at the same speed. Explain why. So you could say that you can see that mass cancels out in the equations, so the mass has no effect on the speed, or you could say that both masses have the same acceleration because gravity is constant. Final question. There can be problems with vehicles travelling too fast down long, steep hills. For safety, there are often escape lanes in the bottom of steep hills. Look at the picture. These escape lanes are filled with sand and sometimes slope upwards. They allow vehicles to stop safely in an emergency when the brakes are not very effective. Explain how these escape lanes can reduce the braking force needed by the vehicle when the driver makes an emergency stop. So, this is the idea that sand provides friction, and going uphill means kinetic energy is lost. And you could also say that the car has less kinetic energy, so less energy is needed in the braking. You could also say that sand absorbs some of the energy of the car, or going uphill increases the drag. So any 2 of any of those points will get you 2 marks. And then in the UK, it is illegal to travel in a car without wearing a seatbelt. Some passengers do not like wearing seatbelts. Write about the risks and benefits of wearing seatbelts for the passengers and for the wider community. So there's 3 marks. So risks, you could say, may be trapped if there's an accident, or there's an accident in water. You could say that it will prevent head hitting the windscreen in an accident, or will prevent being thrown out of the accident in a car. In the wider community, you could say there's a reduction in number of serious injuries or deaths, so the reduction in hospital costs. You could say there's less chance of trauma to relatives due to road accident, but the risk, you could say, there's more chance of injury to pedestrians or themselves, as drivers might be taking more risks because of them. So any 3 of those points. That's quite a difficult question at the end there. You could also talk about the belt injuring passengers in the accident. So you could talk about whiplash or bruising or crushed ribs. And that would also get you a mark. So now you've marked this paper, please add up your marks, add your marks to your poster, and get on with the Unit 2 papers. Thank you.